Good morning, ladies and gentlemen. My name is Trust. Welcome to my website, my rec that I developed almost like, it took me almost like 3 years. If you can't believe this, when I started to build this, I wasn't serious. It was going to be a big thing. But today, I just want to show you how this system works. So government agencies handle thousands of classified documents. Even any other company can do the same thing. Directive, threat assessment, technical reports, analysis, spend hours searching through the manual to find answers. Today, Flow is an enterprise RAG intelligent engine built for sovereign environments. It runs entirely on premises with zero data ingress, GPU accelerated interference, and military grade security. Let me show you what it can do. And as you can see, it is built for classified environments with these features: hybrid retrieval, GPU acceleration interference, persistent knowledge base, end-to-end encryption, built-in evaluation, and full observability. And it contains like 6 containers: one command, zero cloud, fast API, React, Progress, Postgres, SQL, plus quadrant, Q-quadrant, you can call it Q-quadrant, V large learning models or languages, whatever you can call it, and V large learning models are embedding. So let me show you what it can do. I'm going to log into the system and see how it works. So this is kind of like a simple login interface, and access requires a registered account. If you really want to work with it, you need to contact your system administrator to request credentials to use the administration boosted endpoint to create the initial administrator. But more likely, which is government related, is controlled and it's really monitored. So as you can see right now, I'm going to log into the system so everybody can understand how it works. Give me a moment whilst I'm logging in with these login details that I created. So like I said, before it is online, there's no internet, just log in manual. As you can see, I'm in localhost login right now, so I can sign it. And as you can see right now, I'm inside the dashboard. I'm inside the dashboard. As you can see, it's called the command center. So basically what the command center does, this is a command center. It just gives a real-time view of the entire pipeline. As you can see right now, I've got 4 documents in the system with 135 chunks indexed, 1 start session, which is active right now, 6 evaluation that I did before, and 55.0% faithfulness, which is an average grounding score. As you can see right in the middle right here, it's just only showing the storage used, vector store, and large language model engine, which is Olama status, as you can see right now. And this one is a safety health, which shows all your system is up and running. We got Postgres, everything is health, as you can see. And the system also capable for using OCR. So OCR, it's working, everything is good. And deployment is zero egress local. Like I said, it's local. Nothing is online, nothing is internet. And just in the architecture, it's Flow. As I said, it's Flow. That's the name I like to use to name it for my system. Okay, so let's move on to document management. So document management, as you can see right here, I've got 4 documents that I already updated, that I already update and upload into the system, which shows in each document. You can see there's chunks indexed by the system, and this system supports a variety of formats: PDF, Word, TXT, Markdown, CSV, XLS, PowerPoint, HTML, XML, JSON files, ML, MSG, PNG. So the PNG and JP and TIFF files, that's where OCR are coming to play, and it's really beneficial for those documents which are scanned. You can just upload to the system, and the system will retrieve all the written texts for you and pull up the system for you, right? So as you can see, the document management, like I said, we got this, it's right here on the sidebar. The document page shows everything that has been ingested into the knowledge base, as you can see right here. So again, I pointed out all these documents, and each document is automatically split into a semantic chunk embedded into 1024 dimensional vector using BGE large and stored in quadrant for retrieval. And also these documents, they use when uploaded, I explain the format and everything like that. So let's move on to the intelligent system, which is our chat system, which is really very, very beneficial for what we're going to demonstrate right now. So my first query, I'm going to query number one, which is cross-document synthesis. So what I'm going to do, I'm going to paste the script based on what is in the documents. What are the inscription requirements for classified data at rest in sovereign cloud environment? So as I pasted this, I'm going to run it and see how is it going to help us and pull the data. So at the beginning, the system is fresh, still learning, and see how it pull up the information. Okay, and it's fast, as you can see. So based on the system, it pull up this, as you can see. When you see the response is powered by Qwen 2.577B, running on RTX A5000 through VLLM. So I'm using NVIDIA RTX 5000A. So the system uses a hybrid retrieval combining BM25 keyword search with semantic vectors, search, then re-ranks the result with a cross encoder before generating the answer. As you notice, the source citation at the bottom, every claim is traceable, right? Is traceable back to a specific document chunk and scored also based on each score, as you can see right here. This is not hallucination. So most of the people, they might ask, is hallucinating? It's not hallucination. This is grounded intelligent. It's a grounded intelligent, right? So as you can see right here, all right, you can see everything is being processed successfully, okay? So query number two, I'm going to query one more time. The query number two is going to query specific technical details. And let's see how this system perform on specific technical details based on our documents, all right? So what I'm going to pull up right now, I'm going to pull, I'm going to query like what post quantum cryptographic algorithm does the NAS recommend and what are their performance trade-offs. So if I query it, right now it shows you these query targets, as you can see. This query targets the NASA technical assessment. The system retrieved the relevant chunk about SLK, as you can see, SLH, DSL, and Synaptic, then synthesize a clear answer with specific number, performance overhead, signature size, and signing times, as you can see also. This is the kind of analysis that would take an analyst 30 to 50 minutes or an hour of manual searching. Then my system flow does it in a second. As you can see how it performs. Let's query another one, cross-document intelligence. So the cross-document intelligence is really interesting. It's really interesting. I want you guys to see how the cross-document works, and I'll explain after I pull up the data, so I can help you to understand. I can minimize this if you want. Okay, so I push that in there. So like I said, I'm going to test the cross document intelligence and see how this system intelligently combine two different documents and give us the information that we need. So what cyber threat group we identify in Operation Sentinel Shield, and what were their primary targets? Let's see. All right, there you go. Correct. So as you can see, what happened just now, now we are querying the intelligent briefing, that like what I did, the system pulled threat actor designation, TTPs, and targeting information directly from the source material. So every answer includes source reference, so an analyst can verify and drill deeper if he really needs to go into it. All right, let's do query number 4. I'm going to query what we call analytic questions. So it's just an analytic questions and see how it compares the wave process for a cloud infrastructure exemption with the migration timeline for quantum resistant cryptography, and what are the key deadlines. So this is exactly what I'm going to query. So you guys can see how this system is very intelligent in how it pulls the information. All right, just make sure it's well copied and pasted there. Don't want these things to mix. So all right, let's see how it goes. Okay, so what's going on this now? This is where the RAG become powerful, right? I'm asking a question that span two different documents: the DDO directive and the NASA assessment. If you remember those documents I showed you at the beginning in the document section, right? The system retrieved from both cross-reference the information and produce a unified answer. No single document search tool can do this at all. Only this system. When I sit down and start to develop this system, it was kind of just like I was playing around. Of course, most of the people, they might say it's AI. I use AI to code this. No, I'm a software developer by professional. I took my software development at Valencia College, and I also move on to do my bachelor's in software development at Valencia College, and I move on to do my master's in cybersecurity and data science at University of West Florida. So this is straight from my head. I think I just came up with the idea. I want to build a system that can be beneficial to any organization or a government that want to ingest data or ingest their files inside their system and do it locally with no internet connection, right? All right, so let's move on to evaluations. This is the evaluation, and before I did some evaluation. So Flow includes a built-in evaluation framework. Every response can be scored for faithfulness. As you can see right here, I've got faithfulness. Let's see, faithfulness 55% for the other documents. So it combines these faithfulness, as you can see on this one, compare the wave process for cloud infrastructure. So its faithfulness was 85%, which was really good. So as you can see, Flow includes a built-in evaluation framework. Every response can be scored for faithfulness, how well the answer is grounded into the retrieval source. Okay. So the system use RAGs to compute for faithfulness, answer relevance, and context precision. This is how you audit AI quality at scale. All right. Now let's move on to performance tab. So performance tab, as you can see right here, the performance page tracks every stage of the pipeline, embedding latents, retrieval, latents generation, latents, and end-to-end response time. All right. So yeah, the system sometimes is doing like this because I refresh it to make sure it's not causing any issue at all. Okay. As you can see, all these retrieval latents and embedded latents, generation latents, and time to face token is showing in this system. All right. So let's move on to settings. So settings, right? The setting page shows the full system configuration. It's not a big deal, but it shows what's going on with the system, security compliance, pipeline configurations. These are already configured into the backend, so nobody can alter this system, these settings for better quality and everything like that. So the system status panel shows vector score, pipeline configurations, again, and etc. etc. Let's go to admin. This is the main page where the admin can assign or create new users into the system. As you can see, the admin panel provides kind of like a user management API key, lifecycle, and a full audit log inside here. I'll walk you through, as you can see, right? So user management section got API keys, where when you create a new user, the system automatically generates the key, which is rotated and revoked, can be revoked. Rotational is built in for the compliance. Audit logs, every action in the system is logged with a timestamp, as you can see right here, with timestamp, user identity, and the action performed. This is your compliance trail. Very, very important for those who want to audit. All right. So based on the architecture overview, as you can see, the under the hood flow runs at S6 Docker containers, a React front end saved through GIGs with security, like I showed you before at the beginning. So everything is defined in a single Docker compose file and one command to deploy, one file for all the configuration, and 0 cloud dependencies. All right. So lastly, I'm gonna go back to charts again so you can see what happened. So Flow is a production grade RAG intelligent engine designed for environments where data sovereignty is non-negotiable. It's in a hybrid retrieval with cross-encoder re-ranking, GPU accelerated interference with V large learning models or large language models. It's also built in with evaluation, audit logging, and encryption. Full containerized, full locally, and fully sovereign. So this is Flow. This is how Flow works. And lastly, I'm going to show you a bonus under charts. I'm going to ask again, what are the incident response requirements, a sovereign cloud security breach, and what forensic procedure must be followed? All right, let's see how the system behave on this one and see how it retrieved, right? So what are the incident response requirements for sovereign cloud security breach, and what forensic procedure must be followed? All right, let's see what the system's gonna say. There we go, real fast. Okay, so this is exactly what this system does, and all 6 containers are held. And a bonus that I can say, we do a cross documentation to see how it document and combine different documents. We do a threat intel and a quantum calypso and encryption requirement. So again, I can do another one, compare a wave process for cloud infrastructure inception and migration, and see how this system can behave again, which is really the major part I like about this system. and it's quicker and it's faster and retrieve all the information based on what's in the document. Thank you very much for watching. I hope you like this system, and if you need more information, get in touch with me. You can contact me at any time. Good luck. Bye-bye.